Time is experienced the same way by all people. You know the twin paradox. Twin stays on the Earth, the other one gets in the rocket, goes at the speed of light out and back, and when he comes back, his watch and his twin's watch don't match. That's been proven, believe it or not, by having ultra-sophisticated atomic clocks, and they put one of them on an airplane and literally just flew it around the world. And they came back and they found out, yep, the two clocks were off by tiny, tiny amounts, but it was measurable and reproducible. There are 3 space dimensions, length, width, and height. True? Well, it depends on who you talk to. A lot of things in science depend. String theorists, you may have heard of string theory, posit that in order to take into account all of the different qualities that a particle might have, you have to include extra dimensions, as many as 10 or 11, depending on who you talk to sometimes. But some of those are not visible, and I have not yet gotten an answer back from a posting on Facebook in the physics section. What would happen if one of our physical dimensions and one of those curled ones switched places? And then the other part of that answer, so to speak, is that there's time. And in Einstein's relativity calculations and those that went on beyond, and if you've read History in a Nutshell by Hawking's or any of the other works since, and by the way, his new book I think is pretty good.
Hawking's.
But it's Hawking's, and I think it's
Oh, that's good.
Stephen Hawking's latest.
There's one called The Universe in a Nutshell.
Right, and I have that.
Which is not simple.
No, that's a book that's this thick. It takes 3 reads to even understand the words. And believe it or not, I went out and I got books on Introduction to Tensor Calculus and Maxwell's theories and relativity for college students, and it hurts my brain just to think about it. Let's move on a little bit. Okay, so how'd you do on the quiz? Were most of you doing okay?
100%.
Oh, wow, 100%. I'm impressed. Now, the next thing I gave you was 3 pages that I borrowed with consent from a place called The Skeptic's Guide, which is one of the podcasts I listen to. The reason this is important is that people will argue with you about evolution, and if you run across these kinds of arguments, then you know that they've stopped discussing the issue. It's sort of like when it's a game stopper. It's like, saying in a political rally, you're just as bad as Hitler. As soon as the name Hitler comes up, then the discussion pretty much is over. The most important ones that I do want to point out are ad hominem, which is an attack on your person. So if you're discussing evolution and the person who's rebutting or responding says, well, your last 3 books have all been bombs. They haven't sold to anybody. How could you possibly pretend that you know what you're talking about? Did that have anything to do with my talking about fossils? No. It was a personal attack to undermine my character or whatever. And the next one is ad ignoratum. This argument basically says, I have no idea how this could happen. So it must have been by something other than natural means. And this is where you'll hear irreducible complexity, some other things brought up. And basically, this is a person who's saying, I can't figure it out. I don't think anybody will. Therefore, you're wrong and I'm right. The scientist's response to that is, I don't understand it now, but we're making amazing strides. And I think that, at some point we'll probably find a natural answer for that question. Argument from authority, that's me. I'm wearing a white coat. I have numbers my letters after my name. Listen to what I have to say. I am an authority figure. Okay. Just to let you know, this BS is in chemistry and pre-med, which means I pretty much finished the bio major as well. But I have an MD degree. I practiced for almost 15 years. Tried to retrain myself by getting a master's in biomedical and health informatics. And the only reason I put those up there is to tell you that I've been a lifelong learner. If I'm not learning any, I don't care if you call me Dr. Wedgwood or if you call me Jeff or Doc or hey you. Jeff is nice. But that's just to get across the point that I've had a lot of exposure. I want these classes to be as interactive as possible. This first one is an introductory one. It's basically just to get you here to see me and figure out whether or not you think you have an interest in what I have to say. In each class, we'll have at least one experiment. And this is today's experiment, and I think there may not be enough you may have to share. Does this look familiar to you? Wait a minute. You've done this before. I need one back. All right. what I'd like you to do is to take your card and turn it so you're looking at it. And then I have to remember which eye. Cover your left eye, focus on the X, start at arm's length, and then slowly bring it towards your face. And at some point, the little guy's head's going to disappear because it's going to go into your... You have to cover your left eye because your left eye will give you the information. So have you been able to find that?
What are we looking for?
Bring it close up, and the head of the little sketched person should disappear.
His head changes.
It changes, but it doesn't disappear.
But look at the X or the head.
Stare at the X. So you're staring at the X, and you've got a little head over here.
It's bigger, yeah, and the face gets...
Well, I have the X moving over onto the head.
Do you?
In your eye, in the back of your eye, if I were to cut your eye sideways, this is the optic nerve, and our eye is badly designed because there are animals that don't have this, but we have all of our nerves go over the top of the edge of the optic nerve to go in, which means there are no nerves in this actual circle. So if we were to look at the back of the eye turned this way, there's an optical disc if you were to look in the back of your eye, and light will shine. You'll get information from everywhere, especially the macula and the fovea, but no light will penetrate that. So what your brain does is it replaces it with what it thinks would be there otherwise. And in the case of your cards, it should have been, if you were lucky enough to get it just right, it's going to have to be a line.
My head disappears. My card's good.
I can make him disappear. I can make him disappear at will, but the thing is, I can turn on and off my dominant eye. Who did it work for? Where the head disappeared or almost? Okay. What color was replaced by the head?
Just blank.
Blank white, black, purple, green?
No, just blank. Nothing.
Okay. Well.
No color.
No color. So there was no pink, yellow, green. Okay.
Maybe my card didn't work.
Anybody else who it succeeded on? There we go. Right there. For me, at exactly this distance, because I'm nearsighted, his head goes away completely. However, the point was, if you can get this to work, what's filled in is the color of the background. On her card, the disappearing head is filled with orange. On this card, the disappearing head is filled with yellow. On that card, the disappearing head is filled with green. This is because your retina is actually part of your brain. It does a lot of calculations about things that are next to each other in terms of lines, angles, and so on, and movement. And one of the things it does is it does the best it can to figure out what should be there. One of the ways that we deal with our blind spot is that our eyes move, believe it or not, approximately 100 to 200 times per second. They jiggle. Why do they do that? If you've ever had the ability to stare at a point and keep your focus on that point and not deviate and really, really keep it there, and I can do this, everything else fades to black. Do you know why? They get burned out. You have a cell that has plates of what are called rhodopsin, and then light comes in, it goes past these, and hopefully on one of the plates it hits a pigment. That pigment picks up the energy of the photon. That energy is cascaded down to something which makes this change its shape. And that change in shape tells the nerve fire. And there are at least 3 layers of nerves between this and the brain. A lot of layers between this and the brain. But I think it's interesting, if you think about it for the moment, your brain is doing the best that it can, but it's not giving you the information that there's nothing there. And what that means is if somebody could approach you, if you're really focused on something, you're staring at the fire at night after you've killed the caribou or the impala, and you're staring right there, a predator can approach you from that blind spot, and they know it. One of the new things that came out this year in the podcast that I thought was really intriguing thing is that many of you have heard of the amygdala, which is the part of the brain involved in emotion, but it's also a central clearinghouse for senses. So vision, one of the things it does is it sends some information to the amygdala, as well as to the other places that process the visual information. And the amygdala says, association brain, is this related to danger? And if the answer is yes, there is a response, the fight or flight response you've heard about, there's a response that occurs within something like 20 milliseconds. But the visual image doesn't get to your awareness for about 200 milliseconds. So what that means is, although it sounds like a ridiculously short time, there's a period of time where your body's telling you, run like hell, before you're even aware that it's a lion, a tiger, or a bear, or a snake, or whatever, which I think is fascinating.